So today we're going to be looking at the values of exponents that are now rational or fractional exponents. So we need to understand that in this fraction that is the exponent, the numerator is always going to be the exponent value, and the denominator is always going to be the index of the radical. So just a reminder, in terms of a radical, the n value here is what we call the index. So I could rewrite 27 to the 1/3 as really just the cube root of 27. And the cube root of 27 is 3. So we have evaluated or calculated the answer here. Here we have the exponent of 1 and the index of 2. So we're looking for the square root of 0.49. Again, you're very welcome to rewrite 0.49 as a fraction, because this is 49 over 100, because it ends in the 100th decimal spot. So we have 49 divided by 100, which is the square root of 49 divided by the square root of 100, which is 7 on 10. So you could have ended up with 7/10 or 0.7. Either of those is a nice way to write the solution. In this case, our exponent is 1. Our radical has an index of 3. So we're looking for the cube root of -64. So the cube root of positive 64 is 4, and the cube root of negative 64 is -4. And then in this case, we're doing the square root of 4/9, which is just the square root of 4 divided by the square root of 9, which is 2/3. So in terms of writing this in two different ways, we could rewrite this radical as either the cube root of 40 raised to the power of 2. So we could put that exponent outside a pair of brackets here, or you're welcome to put it within the radical. So that's two different ways that you could write this. And then in terms of writing this as exponents, remember, the exponent is the numerator and the index of the radical is the denominator. So we have an exponent of 5 and the radical is a square root. So this would be 3 to the 5/2. And in this case, we have an exponent of 2 and an index of 3. So that's the same as 2/3. So we have 25 to the power of 2/3. So now again, evaluating in terms of exponents that are radicals, and now the numerators have values. For a, this is the same thing as the square root of 0.04 raised to the power of 3. And you could rewrite 0.04 as 4 on 100 if you'd like. Again, 100th decimal spot here. So the square root of 4 is 2, and the square root of square root of 100 is 10. And you're welcome to simplify this fraction before you raise it to the power of 3. So we'd end up with 1/5 to the power of 3. So now this is going to become 1 to the power of 3 and 5 to the power of 3. So we end up with 1 divided by 125. For B, I'll change colors here. We want to take the cube root of 27 and then raise it to the power of 4. So the cube root of 27 is 3, and then 3 raised to the power of 4 is 81. For C, we're looking at -32 to the power of 0.4. So we could actually rewrite 0.4 to be a rational value because this is 4 over 10. The decimal ends in the 10th decimal spot. So this is the same as 2/5. So I'm looking for -32 to the power of 2/5. So I want the 5th root of -32, and then I want to raise that to the power of 2. So the 5th root of -32 is going to be -2, and I raise that to the power of 2 to get 4. And then the last problem, D, So 1.8 to the power of 1.4. So 1.4, it's again 1.4. It's going to be 14 divided by 10 because the decimal ends in the 10th decimal spot, which is 7. Oh, sorry, 7 over 2. Sorry, my mistake in writing that. It actually should have been 7 over 5. Erase that. So I'm looking for the fifth root of 1.8, and then I'm going to raise that to the power of 7. But in this case, there is no natural number or whole number or integer that is the fifth root of 1.8. If you were to put that in your calculator, you'll end up with an irrational value that you would then have to raise to the power of 7. So in terms of simplifying this further, you could definitely just leave it in one of these two forms because that is as simplified as it can get, and it's keeping the preciseness of the answer.